In Python, indentation defines code blocks, not curly braces as in C++ or Java. All statements are indented at the same level, belonging to the same block. If you remove or misalign the indentation, the Python raises indentation error. Every useful program makes decision and performs repetitive tasks. In Python, decision making is done using conditional statements like if, elif, and else. Python evaluates the conditions from top to bottom. First condition true conditions block executes and the rest are skipped. So you use elif when you have multiple decision branches. The for loop in Python iterates directly over a sequence. Here range 1,6 produces numbers from 1 to 5. Loop variable I takes each value in sequence and the body runs once per iteration. The while loop runs as long as condition remains true. We must manually update the variable, otherwise it becomes an infinite loop. Continue skips the rest of the block for that iteration. Break exits the loop entirely. Here 3 is skipped and the loop ends when I equals to 5. Arrays are containers like list but with a key difference. All elements must be of the same type. This makes them faster, more memory efficient when handling numeric data. So you create arrays using array module. When creating arrays, we specify a type code. So it tells Python what type of element will be stored and how much memory to allocate for each. The I type code stands for 4-byte integer and F and D are for floating point numbers. We can access elements in an array using indexing just like list. So index 0 gives the first item, negative indices count from the end. Arrays support many of the same operations as list. You can append elements, insert at positions, remove values. However, all inserted values must match the array's type code. Arrays support slicing. You can extract parts of the array using that notation, the start, colon, end. You can also iterate directly through the arrays using a for loop just like list. So arrays in Python can be nested to represent matrices. Here each row is an array itself. You can access elements using double indexing, first for the row, then for the column. Then functions group related statements together and reuse them whenever needed. Instead of writing the same code multiple times, you define it once and call it whenever required. Python uses a keyword def to define a function, short for define. Defining a function doesn't execute it immediately. You must call the function using its name followed by the parenthesis. When called, control jumps to the function, executes its body and returns to the caller. The functions can take parameters that are special variables that receive data from the caller. Each time you call the function, you can pass different values to it. So these input values are known as arguments. Function can return results using the return keyword. When Python hits return, it sends the result back to the caller and exits the function. The returned value can be stored in a variable, used in expression, or passed to some other functions. Functions receive data with the help of parameters and arguments. Python gives a flexible and powerful way to pass arguments. So positional, keyword, variable length positional arguments and variable length keyword arguments. We will go step by step, show how Python matches the call arguments to parameters. We will learn how to pack and unpack the arguments and the rules for mixing styles safely. First, a quick catalog. Arguments can be passed by position or by name. You can supply defaults, use asterisk args or asterisk kwargs to accept an arbitrary number. Here greet hello Alice passes hello as a first positional and Alice as a second. Python assigns them to parameters by order. So hello goes to greeting and Alice goes to name. Positional arguments are the simplest, so Python assigns values to parameters in order. A swap in order changes behavior or produces errors if you have fewer arguments than parameters. Keyword arguments let you pass values by name instead of position. Keyword arguments are matched by the parameter name and this improves readability, and this is useful when functions have many parameters. You can also mix positional and keyword arguments. For example, positional must come first in the call. Next is arbitrary arguments. If you do not know how many arguments will be passed into your function, add a asterisk before a parameter name in the function definition. This way the function will receive a tuple of arguments and can access the items accordingly. So the asterisk args syntax packs any number of extra positional arguments into a tuple. This is great for functions that accept a variable number of inputs like print or aggregate functions. Inside a function you treat args like a tuple. So asterisk args collects extra positional arguments into a tuple. You can use any name by convention asterisk args, useful when caller may send variable number of items. Double asterisk kwargs gathers any extra named arguments into a dictionary. This is widely used for flexible APIs and forwarding options to other functions. So kwargs and with double asterisk packs extra keyword arguments into a dictionary. This is used when function accepts flexible named configuration. When the asterisk or double asterisk operator is used in the function call, asterisk operator unpacks the data structure such as a list or a tuple into arguments needed by the function definition, and double asterisk operator unpacks a dictionary into the arguments needed by the function definition. So at call time, asterisk iterable expands into positional arguments. Double asterisk mapping expands into keywords. So this is useful to forward arguments or call with dynamic data. So the X and double asterisk operators at the call site do the reverse of that asterisk args and asterisk kwargs. They unpack sequences and mappings into arguments, which is very handy to forward list or dictionaries into functions. In Python, arguments are passed to function using mechanisms like call by object reference, sometimes also called call by sharing. This means that when a function is called, Python passes a reference to the object, not the actual object, and not a simple copy of its value. What makes this concept interesting is that behavior changes depending on whether the object itself is mutable or immutable. If you pass an immutable object like integer, string, or a tuple, the function receives a reference to that object, but since immutable objects cannot be modified, so it is as if you passed a copy. Any changes inside a function create new objects, leaving the original untouched. If you pass a mutable object like a dictionary or a list, the function still receives a reference, but because the object can be changed in place, the original data outside the function can be modified as a side effect. So in summary, Python always passes references, but the effect looks like call by value for immutables and like call by reference for mutables. Here a holds the integer 5. When passed to the function, the parameter x points to the same integer object. Both share the same id initially. Inside the function, when we assign x is equals to 10, Python doesn't modify the existing integer. Instead, it creates a new integer object and makes x refer to that new object. The original a remains unchanged outside the function. This is why immutable arguments like integers behave as if they were passed by value. Now let's see what happens with a mutable object, that is a list. The variable nums and the function parameter L both point to the same list object in the memory. When we append a new element inside the function, the changes happens to the same object. So when we come back outside, nums has been modified too. Notice that the memory ID didn't change. Python didn't create a new list, it modified the existing one. That is why mutable arguments behave like call by reference. So here's a big picture. In Python, everything is passed by object reference. What decides the outcome is whether the object can be changed. Immutable objects behave like call by value, safe and maybe isolated, and mutable objects behave like call by reference, shared and modifiable. So understanding this helps you predict your functions will modify the data and when they won't modify the data. In Python, every function must have at least one statement inside its body. But what if you are designing a program structure that is defining functions now and planning to fill them later? So if you leave a function completely empty, Python will complain with obviously an error because it expects indented block after the def statement. That's where the pass statements come in. Pass statements literally does nothing. It's just a placeholder that tells Python there is no code here yet, but the code block is intentional. You can think of it as do nothing statement that keeps your code syntactically correct while you are still designing or maybe debugging other parts. Regular expressions are one of the most powerful tools in text processing. Think of them as a mini language for searching patterns inside text. For example, finding all phone numbers in a document, or validating email addresses, or maybe replacing words automatically. In Python, we use the RE module to work with regular expressions, and once you learn a few core concepts, it becomes incredibly flexible to manipulate strings. Metacharacters are special symbols in regular expressions that control how patterns behave. They are the real power behind the regex, allowing flexible matching. Now let's explore the real power of regular expressions, that is the metacharacters. Each of these symbols gives a special meaning to your pattern. The dot matches any character except a new line, while that cap anchors the match at the beginning of the string, and $sign anchors it at the end. The repetition symbols asterisk, plus, and question mark controls how many times a pattern repeats, from 0 to more, or to 1 or more, or even optional. You can also specify an exact count using curly braces like m, n. For example, d of 3 matches exactly 3 digits. Square brackets lets you define sets of allowed characters, while parentheses group parts of your pattern so they act as one unit. And finally, backslash escapes a meta character, allowing you to match it literally. For instance, match dot matches a real dot instead of any character. Let's begin with the dot meta character. The dot matches any character, any single character, letter, number, or symbol except a new line. Here the pattern c dot t matches any 3 character sequence starting with c and ending with t, no matter what is in the middle. That's why cat, caught, cut, and even cbt are all valid matches. But notice quote didn't match because it has 4 characters, not 3. The asterisk means 0 or more repetitions of the preceding pattern. In the pattern so asterisk, the letter is followed by 0 or more zeros. So it matches S alone. 0 O's are allowed. So S with double O, or even S with 4 or 5 O's. So these are all valid. So this is useful when you want to match something that might repeat or might not appear at all. Now the plus is similar to the star, but it is more, you can say, it is more strict. It means 1 or more repetitions. So the pattern so plus will match so, and so on, but not the word lone S, because at least 1 O is required. Think of asterisk as maybe present and plus as definitely present at least once. So to summarize, dot is a wildcard for any one character, star allows the preceding element to appear 0 or more times, and plus allows it to appear 1 or more times. These 3 meta characters form the foundation of almost every regular expression. So they let you describe repetition and variation in a single compact pattern. The question mark makes the preceding character optional. In this case, this matches both color with COLOR and COLOUR. If we wanted exactly 3 digits, we could use curly braces 3. For example, D of 3 would match something like, for example, 1, 2, 3. The caret in the symbol ensures that pattern appears only at the start of the string, and dollar means checks for the patterns at the end. The vertical bar acts like a logical OR. Here it finds either the cat or a dog. Similarly, character sets allow matching any one character from a group. Notice that we use this sign. Without a backslash, the dot would match any character. By escaping it, we tell the Python to treat it as a literal dot in the file name. That's why writing raw strings using the prefix R before quotes is so important when using regular expressions. So Python's regular expression engine gives us a strong and easy to remember escape sequences. /d represent any digit, /w any word character, and /s matches any white space like space, tab, or a new line. Their uppercase counterparts are like these. These shortcut makes complex patterns much more readable and faster to write. The re.sub function allows you to search and replace parts of the string based on the patterns. Here, every mention of Python followed by a version number like 3.10 maybe or 2.7 is replaced by the text Python version hidden. The split function can be used to break a string into a list using a regular expression delimiters. So in normal Python strings, a backslash is an escape character. For example, \n means new line. But in regular expression patterns, we often need literal backslashes. That's why we use raw strings prefixed with an R. So R of this means match one or more digits followed by a dot followed by one or more digits, exactly as written. Let's end this discussion with any practical example of email validation. This pattern checks that an email starts with letter, digits, or symbols like dots or underscores, followed by an @sign, a domain name, and finally a valid extension. Regular expressions like this are used in logging forms and data cleaning tools everywhere. The match function checks if the pattern matches only at the start of the string. Search scans the entire string for the first occurrence of the pattern to start at the beginning. So if even if Python appears in the middle, search basically finds it. Find all return list of all the matches in the string. Each match is extracted as plain text. Unlike find all, find iter doesn't just return strings, it returns match objects, giving more details such as start and end positions. This is very useful for highlighting or replacing text at specific locations. The sub function replaces all occurrences of the pattern with another string. You can use this for cleaning text and for again formatting data. So these functions are the workhorses of you can say Python's RE module. You will use them for text validation, search and replace things, and data extraction, parsing logs and documents. So together they let you search, find, locate, and modify the text patterns with precision. So in this part of our journey, we explored the core building blocks of Python, from installation to setting up Python to understanding the data types, the flow control, functions, and recursions. You now have the foundation needed to move into object-oriented world of Python. In our next session, we will take everything you already know from C++ OOP, the concepts like classes, objects, constructors, inheritance, polymorphism, and see how they translate beautifully into Python's simple and more flexible syntax. So stay tuned. In the next session, we will start mapping each C++ OOP concept to its Python equivalent side by side to help you transition smoothly from one language paradigm to the other. So thanks for watching, and I'll see you in the next session.